another way of drawing your Born-Haber cycle, which is energy level diagram. Okay, so we will start with formation. Okay, ingat kita guna F, E, I, E, L. So first, formation of your solid ionic compound. Okay, for energy level diagram punya drawing ni, you need to notice that you have this y-axis that says enthalpy. Okay, and then you denote daripada awak punya stable state element tu, enthalpy dia 0. Okay, and notice that your delta H of formation is an exothermic reaction, right? So exothermic reaction means that your arrow will go down, so you're going to release heat. So exothermic reaction, negative delta H means that your arrow will go down. Okay, so kalau endothermic, dia akan naik atas lah. You're going to absorb heat, so enthalpy change to positive. Okay, and then you are going to do atomization of your lithium. Atomization of lithium is an endothermic reaction, so awak punya arrow naik atas. And notice here you are changing your lithium solid atom into lithium gas atom, right? Next, you're going to perform another atomization for your fluorine atom. You want to form fluorine atom. Okay, so you are going to form here from half F2. In gaseous state, you're going to form one fluorine gas atom. So this step is an endothermic reaction, so you are absorbing heat, maksudnya arrow awak naik atas. Okay, the thing with doing this energy level diagram, you will need to start slowly to cungap skill lah nak buat ni. Okay, you know, it's new for you. Next, you're going to do ionization energy. So ionization is an endothermic reaction, so naik atas. Okay, apa yang awak tengah ionize ni? Your lithium gas. Jadi this one. Okay, you have to do step by step. Okay, awak tak boleh combine delta H1 dengan delta H2 sekaligus je buat. You have to do step by step. Delta H1 dulu, lepas tu delta H2, then delta H3, and then so on. Right, so your next step is electron affinity. So that means that your fluorine gas here, you are going to accept electron. Okay, so electron affinity, the first electron affinity is an exothermic reaction, therefore your arrow is going to go down. Okay, here to form this gaseous ion. Okay, and then what? You're going to find the lattice energy. So dah dapat gaseous ions, you will now do your lattice formation of your solid ionic compound. Okay, so you're going to find lah what is this. So for this one also, you are going to do yang clockwise and anti-clockwise too. So what we're going to do is, we are going to start here kat 0 ni. Okay, so 1 naik, and then yang ni sampai sini. Okay, that is your clockwise. So campur semua delta H ni, delta H1, delta H2, delta H3, delta H4 and delta H5 equals to yang anti-clockwise, which is this one. That is your enthalpy of formation, your delta H overall. Okay, so and then do that and then rearrange to find your delta H5. Okay, you can rearrange, okay, to find your delta H lattice, right? Alright, for example 2, let's see, this is a different kind of question. By using the following data, construct the Born-Haber cycle for an ECl solid and calculate its lattice energy, delta H lattice. So, kalau before this, okay, they did not give you the chemical equation, but they gave you the name of the reaction, right? But here, they gave you the chemical equation, but they did not give you the name of the reaction, okay? So, you need to identify what delta H is each of this, alright? So, the first one, from sodium solid to sodium gas atom, This is atomization, right? And then we have Cl2 gas molecule turning into 2 chlorine gas atoms. So this is also atomization. Or another name for it is bond energy or bond dissociation, because Cl2 gas molecule looks like this, and then you dissociate, you break this bond, so dia dapat 2 Cl atoms, okay, in gaseous state. Next we have sodium gas turning into sodium plus gas ion. Sodium plus gas ion. So here we have electron, that means this is removing electron, so IE, alright, IE1 to be exact. Then we have this, you are gaining 1 mole of electron, so this will be electron affinity. And then here, finally, we have formation of our NaCl ionic solid from its most stable element, right? So this will be delta H formation, okay? Once you know all that, you can use the sequence, okay, and draw your Born-Haber cycle accordingly. So the energy cycle diagram for that question will look like this, okay? And macam biasalah, we start with formation, and then atomization, okay, and then ionization, and then electron affinity, and then lattice energy. But I want to point out right here, okay, right here, for the atomization process, okay, we divide it by 2. Why is that so? If you look back here, okay, the thermochemical equation given is for chlorine gas molecule forming 2 chlorine gas atoms, okay, but we want to have 1 chloride ion gas, okay, that will be formed from 1 chlorine gas atom, okay. So that means kita nak satu saja, we want 1 here. So you will have to divide by 2 the whole equation, okay, divide. So dapatlah 1 je. Kalau awak guna this one, you will get 2 chlorine gas atoms. We don't want that, okay. So that's why you have to divide by 2. Alright. So and then macam biasa, you use clockwise equals to anti-clockwise, you can find your delta H lattice energy. So here we have the energy level diagram, okay. So if you want to do it this way, make sure to have your y-axis with enthalpy and denote your 0 delta H, okay. This will be for your stable state elements, alright, starting with sodium solid and half chlorine gas molecule, okay. And then make sure when you do your arrows, okay, you cannot combine delta H1 with delta H2. You have to do it one by one separately. Delta H1, delta H2, and then delta H3. You have to do one by one, okay, tak boleh combine. And then ikutlah awak punya exothermic and endothermic, okay. Exothermic maksudnya you release heat, so the arrow will go down. Endothermic, you are absorbing heat, so you will go up for the arrow, okay. And then just use anti-clockwise equals to clockwise to find the lattice energy, okay. So this is the calculation to find your lattice energy of solid ionic compound NaCl, okay. Make sure that you will get it in negative because this is lattice formation, okay. So how do we know if the ionic compound is stable or not, whether it exists or not? So we're going to use Born-Haber cycle to predict the stability or existence of our ionic compounds, okay. How do we do that? Actually, we will be looking at the magnitude of our standard enthalpy of formation, your delta H naught formation of your ionic compound. If your delta H formation is more negative, okay, if it is negative, then it is considered a stable compound. That means that it can form at standard condition, okay. If it is more positive, that means it is less stable lah at standard conditions. Alright. Another thing is we can look at the lattice energy. Macam we said earlier, okay, the larger the lattice energy, the more stable the solid, okay. So this exercise 4, they ask you to construct the Born-Haber cycle and then explain why NaCl2 cannot form under standard conditions. Why is that so? So awak kenalah construct your Born-Haber cycle, and then you will find that your delta H formation is positive. Okay, so and then you have to deduce maksudnya you have to state the delta H formation that you found. Okay, this one, and the reason why it cannot form at under standard conditions. Why is that so? Because it is unstable. Okay, and why do you say that it's unstable? Because the delta H knot formation is highly endothermic. Okay, so that's how you reason. So we're done with 2.4 Born-Haber cycle. So make sure to do all examples and exercises and finish your remaining tutorial questions. Okay, thank you.